Hi guys. So we did a whole bunch of labs where we looked at matter interacting either with energy or with each other, and we tried to determine whether or not those interactions were chemical or physical changes. And sometimes it was a little bit difficult to know, but hopefully you started to get good at this. There's certain things you should look for when you're looking to determine whether or not something has changed chemically or physically. And there are also certain things that people assume necessarily mean that a chemical change has happened, but actually not necessarily. So just think back on all those labs that we did and think about the observations that you made and which observations were good observations that told you for sure, something chemical has happened, and which ones were just observations that could have meant a chemical change, but could also have just been a physical change. And I'll give you a couple examples here. In the upper left-hand corner, you'll remember we did 3 labs where we just added a substance to water. And I had you very deliberately do that using a balloon as a gas trap device, in case any of those chemicals, when added to water produced a gas. And if you think about it, this is a really simple way just to see whether or not a gas is being created. Now, it turns out that only one of the 3 substances that we put in here had anything in it that reacted chemically, and only one of them went through a chemical change. That would have been the Alka-Seltzer, which caused the balloon to inflate because a gas was created as the particles inside of the test tube started rearranging themselves and turning into new substances. That's a pretty strong indication that a chemical change has happened if you get a gas without heating your substance. So you have a substance, it's either a liquid or a solid, you're not heating it, so then why would it turn into a new state? You're not cooling it off, you're not heating it, so it shouldn't change state. You're not changing the pressure really. So all that's happening is you've given it a chance to react chemically with another chemical, and the results have produced a new gas. And you can even test that gas out when you're done. There's enough gas left in the test tube after you remove the balloon that you could put a splint in there. And we did this. We put a little splint in there, a lit one, and it goes out. And that's because Alka-Seltzer and water produce carbon dioxide gas. So those were pretty strong evidence that a chemical change had happened. However, a lot of times students think when they add the salt to the water that the salt has gone through some kind of chemical change because it appears to disappear. It's no longer a solid, and so that seems sort of chemically, because that's a state change too, right? Your salt went from being a solid to apparently being liquid, like the liquid water. But actually, all that happened to your salt is it got spread out through your liquid, so it's further apart than it used to be, so you don't see it anymore. But the water still tastes salty if you were to drink it, which you can't do in our lab. So to help show you that the salt was still there, I had you evaporate away the water, and hopefully if you did this, you noticed that the salt came back as soon as the water was gone. So it was there all along. So no new substances form when salt is added to water. The same thing would happen if you heated the copper sulfate in water mixture. No new substances form when you add copper sulfate to water. It just dissolves. You can still see the blue powder mixed in. And if you were to heat it, you would get that water to evaporate and the blue powder would stay behind. Another good indicator of a chemical change is what happened in the bottom of this bottle before we did the flaming splint test. I apologize, I mean the glowing splint test, right? It's flaming now, but it was glowing when you first put it in there. We mixed together 2 chemicals here, a clear liquid called hydrogen peroxide. We put that in first, and then we added a spoonful of that black powder, manganese dioxide, and right away you saw bubbling and fizzing, which is a pretty good indication that a chemical change is occurring because, again, bubbling is due to a gas forming. So there's a gas forming down there in that hydrogen peroxide that wasn't there before, and we're not heating it. So that must mean that a chemical is changing what it's bonded to in order to form a new state. But the other cool thing that happens if you hold the bottle with your bare hand is you begin to feel it heating up. And again, we're not heating it, so where does that heat energy come from? Well, it actually comes from the atoms themselves as they break apart. They're chemically bonded to each other. And we've talked about this before, that when 2 atoms are bonded to each other, it's almost like they have a rubber band wrapped around them that's holding them together. And that bond is like an attraction, like between 2 magnets. And if you stretch that rubber band enough, it'll snap. Well, what would happen to 2 things held together by a tight rubber band? If the rubber band snaps, aren't they going to fly apart from each other? which would mean they'd speed up. And what happens when atoms speed up? Well, that must mean the temperature goes up. So that's why you feel the bottom of this test tube heating up. It's because the atoms are actually breaking apart their bonds, and when they do that, they release a ton of energy. They produce oxygen gas as the new compound, and it's up at the top of the bottle, and when you put a flowing splint in there, it reignites on contact. In this lab, we're going to heat baking soda, and the question before the class is this a chemical change or a physical change? Sometimes you get both chemical and physical changes, but it's one of those three things. Either it's a physical change, a chemical change, or both are occurring at the same time. So how are you going to figure this out? Well, no matter what, there are certain things you have to look for. You won't know in advance of doing the lab, but you're going to be placed on one of two teams. Team 1 is going to be the prosecution team, and the job of the prosecutor is to prove beyond a reasonable doubt that new substances form during the new lab. So when you heat your baking soda, you're going to look for evidence that new substances formed. Now, evidence can be strong or weak. So there's really two different kinds of evidence that you need to collect. There's what we call circumstantial evidence, which is evidence that could support the idea that a new substance formed, but it's not definite, it's not for sure, it's not conclusive. And then there's evidence that if this happened, if you really have good evidence that this happened, that means a chemical change must have occurred. So look at the list, you've seen it before, and start thinking about this. When you run the lab, the baking soda lab, you're going to need to look for these things: a state changing, a color changing, volume changing, bubbling, smoking, whether or not the substance reacts differently after it's been heated than it did before to any chemical you can think of, whether or not there are any energy changes that come out of nowhere like we saw in the previous labs that I described. You might also wind up on the defense team, and the point of the defense team is to create in the minds of the jurors reasonable doubt. You want those jurors to be like, well, maybe, but maybe not. Maybe there was a chemical change, maybe there wasn't. To do that, you're going to have to demonstrate that new properties that did occur are not due to the new substances being formed. So if there are new properties, you have to be able to explain those properties away as physical changes. So for example, if the state changed, you need to be able to say, well, the state changed because we changed the temperature. And as soon as the temperature was brought back to where it was before, the state went back to being what it was when we started. Any change you see, you need to explain as being some kind of physical change and not the rearrangement of atoms. And if you're the defense team, and you see one of these things happen, you're really going to have to work hard to explain that away, because that's a really good strong sign that a chemical change has happened. It could have happened, you could have gotten data that shows that this happened incorrectly or in error, in which case you might want to say, well, look, we think that data point is suspect, but you better have good evidence to back that up. This would be like if, for example, the prosecution in a criminal case were to say, well, the murder weapon has your fingerprints on it. And then the defense would get up and say, well, we think those fingerprints were incorrectly identified. They're not really the fingerprints of our defendant, like that. So you have to think about all these things if you're on the defense team. Oops. But really the first part of this is figuring out what tests you should run and what data you should collect as you heat your baking soda. I'm going to give you a basic lab procedure, but it's going to be up to you to figure out, beyond just heating the baking soda, what else do you need to do in order to make sure that you've collected enough evidence to fight the case in court. And since you won't know whether you're going to be on the prosecution or the defense, you're going to need to collect as much data as you can so that you can figure out in the end which side you're going to argue. You could also wind up on the jury. You could be one of the people who's going to help decide whether the prosecution or the defense has made the case better. So think about this. What tests can you run that will ensure that you're able to observe all of these things? That's what you're really tasked with doing during the lab. After the lab, you're going to take the data you've collected and use that to make your case. Okay, so your next step is to preview the lab procedures. It's a little 6-minute video explaining the techniques that you're going to use as you heat the baking soda. It's from an old, outdated version of this lab, so you'll hear me referring to the lab sheets, and sometimes the lab sheets I'm referring to won't match up with the current lab sheets. For example, I tell you in the video that you have to draw the setup, but you don't, because I took a picture of it because we now have iPads. So the picture is embedded for you with little labels, so you can just label it yourself without having to draw it. And there's probably other things like that. For example, I talk about forming an if-then hypothesis, and I no longer teach it that way, so you guys don't have to worry about that. What's an if-then hypothesis? And you never heard of that, so don't worry about that. So any little differences between the tutorial and the lab sheet, just ignore. But you do want to fill out the lab sheet up to the point where you are supposed to start collecting data. You'll obviously collect data in class, and you'll write and answer the conclusion questions later. I will collect these lab sheets. They are worth 50 points, but the bigger part of your grade is going to come from the presentations you're going to do in class on whether or not you think the baking soda has gone through a chemical or a physical change. So have fun watching that video, and I'll see you guys in class. Hope you're enjoying your snow day.